Hello, good evening. It's Mindy. You read all these good hellos. Hello, good evening. Oh, I can try to check on your hours, but I won't be able to check on your hours till like a break time if you're asking. Hopefully everybody can hear me now. I am supposedly teaching on Sunday. Good evening. Perfect, everybody can hear me. Okay, let me type back to the person who said they can't hear me. All right. Yeah, so you guys had a good okay, perfect. Speak of next week. So next week is the last week of class. So final on Sunday, and then Wednesday night is the last night of class. So those of you who are, I should give this a couple minutes, huh? Good evening. Have everybody check in. My son is trying to come in and out as fast as he can and not make a lot of noise. So yeah, so final on Sunday. Then Wednesday night is the last night of class. Anyway, so those of you who said they were going to do extra credit, could you please have your extra, if you're going to have something that needs to be uploaded, can you please have that to Dan by Sunday night so that he has time to upload that into the program for us to share with everybody? He asked that that be done by Sunday night. And I think there was only a couple people going to do that. But I'm just making sure everybody knows. All right. So you had a good class about digestion. On Sunday. Yeah, no problem. Okay. So we are really in the home stretch. So we're going to do finish up our structure tonight and do our review for digestion. Did you guys have time to do the ABMP review in digestion also on Sunday? The ABMP quiz? Okay, perfect. So we're going to go through that and structure, review, and then review for the final so that you guys have all good study materials and you will be ready for your test. Sounds amazing, right? So, okay, it's 5 after now. So hopefully everybody is here. Once again, if you are doing a sense group for next Wednesday night, please, if you need it uploaded into the program, have that emailed to Dan by Sunday night. By Sunday night. And I will probably remind you again on Sunday, because we all are a little forgetful. All right, so let's get our structure books out and our papers so we can take notes. Get this up and running. So get out your blue book for structure. Get out your grid paper so you can take notes. And this over here. Is my person that was having trouble hearing me before able to hear me now? So Crystal, are you able to hear me? Oh, thank you for letting me know you're doing makeup hours. That's super helpful. Okay, so no, you can't hear me. Okay. Hopefully. Okay. She saw that. Perfect. All right, so let's see, well, who's in our first slide? Ooh, we got 3 in our first slide: indicus, pollicic, and minimi. So indicus, page 45. So what I want you to know for this is indicus is your pointer finger. Okay, indicus is your pointer. So indicus is your pointer finger. You can see here that it's coming off of the ulna and it's coming down onto your pointer finger. So this is an extensor. It's going to pull your finger back towards your forearm. Okay, pollicic. Put page 45. Pollicic, the one in the picture they want you to see is on page 47. And this one's on your thumb. Okay, all extensors. All right, so this one is a longus. So you know there's a brevis, which is on page 48, but we just want you to know that pollicic means thumb, indicus is your pointer finger, and then minimi is going to be page 53. Hold on. Trying to see if it's the same picture. It has to be. Okay. This one is page 53. And this one is a flexor. These two are extensors. Okay. Yeah, minimi. So minimi means pinky, right? So pink is telling you which finger it is, right? It's the 5th digit. So we also call that the pinky. So the other way to do this, right, is to go by your digits. Your first digit is your thumb, right? Your 5th digit is your pinky. So you could look at them that way also. No, this is it. We're on the first page. No, you don't need to know the origin, insertion, all that. You just need to know that indicus is your pointer, which is your 2nd finger, right? Your 2nd digit. Your pollicic is your 1st digit, your thumb, and minimi is your 5th, which is your pinky. Oh, I'm so glad you got your sound working. It's very helpful. Okay, so that's those 3. But if you look for minimi, it's page 53, 54, 55. All of those have minimi on them. They're just different because they're all on the pinky, but they're a little bit different muscle group. For one's an abductor and one's an opponent's. So, but we're looking at the flexor. Okay, so the page numbers, you should have them on your paper, is 45, 47, and 53. And then we want you to know which digit they go with. I'm going to scroll this for 1 second. Yeah, that's it. Okay, everybody good with this? Because I have a trail guide video, 2 actually. Good. Okay, let's go to sharing. I don't like it when it does that. Panel. All right. Let's see. Let's start with the extensors of the hand and wrist.
There are 4 extensors of the wrist and fingers. They are situated between the brachioradialis and the shaft of the ulna along the forearm's lateral and posterior surface. All of these muscles are superficial and accessible, though challenging to truly isolate. Extensor carpi radialis longus and brevis are lateral and posterior to the brachioradialis. Extensor carpi ulnaris, as its name suggests, lies along the ulnar shaft. And extensor digitorum is located between these muscles and has 4 long superficial tendons stretching along the dorsal surface of the hand and fingers. The extensors of the wrist and fingers. Less bulky than the flexors, more sinewy. Let's see if we can get a handle on them. I'm going to begin by just isolating the 2 structures that separate the extensors from the flexors. The first is going to be the brachioradialis. So go ahead and make a fist and try to bring your hand toward your shoulder. And there, right there on the top of the forearm, we see the brachioradialis. That's that one structure that's going to separate these muscles from those. And then relax. And then on the underside of the arm, we have the shaft of the ulna running from the olecranon process all the way down to the head of the ulna. A very superficial ridge. So we've got the shaft of the ulna and the brachioradialis, and in that space will be the extensors. So let's see these muscles engaged. I'm going to ask my partner to just go ahead and extend the wrist. Wow, and there's a great example of the extensor carpi radialis longus and brevis. And then next to it we have the extensor digitorum. And then last, right next to the shaft of the ulna, we have the extensor carpi ulnaris. Good, and relax. So let's begin by just isolating the key bony landmarks where all of these extensors attach. And that's going to be right here at that lateral epicondyle of the humerus. So it's right here on the lateral side of the elbow, very prominent. And secondly, the lateral supracondylar ridge right here, just up from that epicondyle. Good. And so those landmarks will be where all of these extensors attach before they come down and insert into the wrist and fingers. Good. So let's begin with the 2 that are right next to the brachioradialis, the extensor carpi radialis longus and brevis muscles. Go ahead and try to flex your elbow again. Great. So there's his brachioradialis, and I'm just going to set my thumb right next to the edge and go ahead and relax. And right there is the tissue of the extensor carpi radialis longus and brevis. And go ahead and just try to swing your hand this way. Great. And as he tries to abduct the wrist, I can feel these bellies really engage. and they become somewhat tendinous about halfway down the forearm before they finally attach here at the bases of the metacarpals. Good, and relax. So we've got the brachioradialis, the extensor carpi radialis longus and brevis, and then we have the digitorum. And if I ask my partner, just try to act like you're typing a little bit, playing on the piano. Wow, there we can really see the undulating effects of the digitorum right there. So I'm going to just set my thumb right into that space, and I can follow it proximally to that lateral epicondyle. And then I can roll my thumb across it. And go ahead and type again. Oh, yeah, this is really interesting, engaged, very much engaged tissue right here. Good, and relax. And then about right here, that muscle belly gives way to tendons and passes down the back of the wrist where it finally attaches at the end of the fingers. And last but not least, after the digitorum, we have the extensor carpi ulnaris. And if you're not quite sure where it is, you can always even start at the shaft of the ulna right there and work your fingers over. And that large, bulky belly is the ulnaris. And I'm going to ask my partner to just swing your hand that way. That's right. So he's adducting at the wrist. And there we can feel and even see that ulnaris engage. And there we see its distal tendon passing by the wrist. Great, and relax. So finally, we can shorten the extensors by extending the wrist and extending the fingers, and then I can lengthen them by flexing the fingers and flexing the wrist. Good.
Well, okay. I'm going to hold on. Do we have ones for those? I don't. Okay, so I don't have ones for those. Okay. All right, so he just talked about extensor carpi. So go to page 39. Page 39 in your book. Let's see what we can see for right now. Can we not see me? Oh, there we am. Okay, so 39 is extensor carpi radialis longus, right? So what you need to know is it's a group of muscles that extends the wrist. A group of muscles that extends the wrist. This. Oops. All right. I haven't used this before, so we can see if we use this. A group of oops. The list. Okay, so that's what you need to know for page 39. Okay. That's all you need to know for page 39. So that's extensor carpi radialis longus. All right. So if we go, it's too small. I'm new at this. Hold on. How do I make it bigger? How's that? That is extensor carpi. Yes. All right. Extensor carpi. So the next one is going to be page 31. Flexor carpi. I don't have slides for these. And it's a group of muscles that flexes the wrist. Group muscles that flex the wrist. Okay. So that's what you need to know for page 31. Flexor carpi radialis is going to be a group of muscles that flex the wrist. Okay, so the next one is page 42. Extensor digitorum. Extensor digitorum. So these extend the fingers. So I can't even see me. So when I say extend the fingers, your hand is like this and you're extending the fingers. So you're coming back. Extension. So these well, this one isn't so much a group because it's, I mean, I guess it's a group. It's just one. If you look at the picture on page 42, you can see that it's a big muscle. expands over 4 fingers. Starts as one big muscle, yeah. On the lateral epicondyle of the humerus. Yeah. Oh, now my camera's working. How weird. So, pulls back. Extension. So, massage therapists, we massage like this, right? And we do a lot of this. So our hands need a lot more of this stretching, especially our fingers. We need to stretch. Did you hear my finger pop? You stretch. Make sure you do individual fingers. Physical therapy has like this, it's like a webbing, but it's like rubber. So it's like it's a circle, it looks like a web. So you push your hand in it and it has a little give, but every time you do it, so it's to strengthen all of this here, right? Your extensors, gives you a little, you know, give a little more push and a little more push to like stretch all this out, like strengthen this and to stretch here. So it's kind of cool. All right, flexor digitorum. I don't have a page number for this one. I couldn't find it quickly. So let me see if I can find a flexor in the back of the book here. Flexor digitorum. Flexor digitorum. What do we want to go with? Well, my guess is those are going to be in the feet. $36 maybe. Sure. We'll go with page 36. Maybe I said 35. 35 works. 35 and 36. We could use either one. Now page, oops, 35, 36. And this is flexor. Oh yes, everything's gonna go great tonight. And they flex the fingers. So flex, they flex the fingers. So we're talking about flexors of the fingers. Okay. So we just watched the video on the extensors, right? Yes, thank you. So we're going to watch the video on the flexors.
There are 5 muscles that create flexion at the wrist or fingers. They're located on the forearm's anterior and medial surface between the brachioradialis and the ulnar shaft. Most of the flexors originate as one mass from the common flexor tendon at the medial epicondyle of the humerus. And the flexors are arranged in 3 layers. The superficial layer is formed by the long bellies of flexor carpi radialis, palmaris longus, and flexor carpi ulnaris. All 3 are palpable. The middle and deeper layers contain the wide bellies of flexor digitorum superficialis and flexor digitorum profundus, respectively. So since the forearm is packed with over 15 different muscles, 5 of them being the flexors of the wrist and fingers, let's take this step by step. I'm going to begin by just isolating the 2 structures that divide the flexors here on the medial side of the forearm from the extensors. And the first is going to be that brachioradialis muscle we see there on the top of the forearm. Go ahead and make a little fist and try to bring your hand toward your shoulder. Great. So as he tries to flex his elbow, there we can really see the brachioradialis pop out on the top of the forearm. So that's one dividing line. The second dividing line is going to be the shaft of the ulna here, running all the way from the head of the ulna all the way down superficially to the elbow. And all of this tissue in between those 2 structures is going to be the flexors. Good. So if I want to see these muscles engaged, go ahead and just curl your fingers and then curl your wrist. Sort of flex your forearm there a little bit. Great. And all of this tissue here, really very contracted now that he's flexing the wrist and the fingers, that's going to be the flexor group right there. Great. Go ahead and relax. And I can really get my fingers on it now. Very fleshy, muscular group, unlike the extensors, which were more sinewy. Great. Very, very pliable and malleable. So unlike the extensors, which are arranged in a side-by-side pattern, the flexors are arranged in 3 layers. The first layer is going to be comprised of that flexor carpi radialis, in the middle the palmaris longus, and then over here on the ulnar side is the flexor carpi ulnaris. And they make up that first superficial layer. And if we take those away, we can see the middle layer, which is the flexor digitorum superficialis, and deep to that is the flexor digitorum profundus. So those are our 3 layers of the flexors. Well, let's go back to that superficial layer for a moment. So the bulk of this tissue of the flexors is comprised of that second and third layer. So the 3 superficial ones are not very big and span right across the top of the forearm and penetrate into the hand. And the easiest way to get your hands on one of those muscles or tendons is right here at the wrist, where these muscles are very thin tendons. So if I ask my partner, just go ahead and try to like squeeze a basketball. There you go. Do you see that tendon right there, right in the middle, sort of running right into the middle of the wrist? That's the palmaris longus. That's that one that was in the middle. And then go ahead and relax. And if you just try to abduct your wrist a little bit going that way, do you see this tendon here? That's going to be the flexor carpi radialis. And then go the other way. And as he adducts his wrist, here is the tendon of the flexor carpi ulnaris. Great. And those 3 tendons can be a great jumping off point to access the bellies themselves. So let's do that. So go ahead and relax your forearm there. There's that flexor carpi radialis tendon. And as I follow it proximally, it's really quite small. It's not a very thick, round belly. It's sort of flat in a sense. And if I ask my partner again to just try to abduct your wrist a little bit, that's great. There, that muscle really engages. And I can follow it all the way down as it descends and attaches to the medial epicondyle. Great. So that's the flexor carpi radialis. And then in the middle, we've got that palmaris longus. And There again, it becomes more muscular. And go ahead and do that palming of a basketball again. Now, as he tenses his palmaris longus, this belly really engages right there. And again, it's heading right to that medial epicondyle. Good, and relax. And last, we've got that tendon right here, which is the flexor carpi ulnaris. It attaches here at the pisiform, that little tiny carpal bone right at that flexor crease. And then I'm going to just follow it proximally and go ahead and shift your wrist the other way. I'll give him a little resistance, so he's going to try to adduct, there you go, that way. And sure enough, as he tries to adduct his wrist, that belly really engages. Now, what's interesting to notice is that this belly right here does not lay next to the shaft of the ulna, which is here. There's like a little gap right here, right along the shaft of the ulna. And we're going to get to that in just a moment. So we've got 3 superficial flexors running down the front of the forearm, and then the next layers, the flexor digitorum superficialis and profundus, are really going to make up most of this tissue, like I was saying. And if I ask my partner, just try to type slowly with your fingers a little bit, so as he tries to flex his digits, wow, I can really feel the undulating quality of these deeper flexors underneath my fingers right there. Great, relax. And so all of that mass under there is going to be these deeper flexors. And remember that gap that was right next to the shaft of the ulna? Well, if I set my fingers right on the edge of that ulna and then sink into the flexor area there, and then go ahead and type a little bit more, and as he tries to wiggle his fingers, wow, that's really like a great side door to access some of the flexors right there. You can really feel the profundus and digitorum as they contract and relax as he does that. That's great, and relax. Good. So finally, if I want to shorten the flexors, I can passively flex the digits and the wrist and the elbow. And to lengthen all of these, I can extend the elbow, extend the wrist, and extend the fingers. So to lengthen and then to shorten. Great. And that's just a little bit of something to get you started on the flexors of the wrist and fingers.
Perfect. Okay. All right. Ooh. Take these away. All right. Sternocleidomastoid. 154. Page 154. Sternocleidomastoid. It's a great muscle, as in its name, tells you where this muscle is going. So we have 2 attachments here, one on the sternum, one on the clavicle, and then one on the mastoid process. So the O for osteo, for bone, tells you it's a bone. So stern for sternum, clyde for clavicle, mastoid for mastoid process. So origin is the manubrium of the sternum and the medial clavicle. And the insertion is the mastoid process of the temporal bone. It's a really good one to work on if somebody has a headache. 154 in the blue book, yes. The actions are bilateral extension of the head and flexion of the neck. Okay, here you go. So bilateral, both sides. Sternocleidomastoid. This is the muscle we're on, sternocleidomastoid, page 154 in the blue book. So by two sides, extension of the head and flexion of the neck. And unilateral, uni for one, lateral flexion of the head to the same side and a rotation of the head and neck to the opposite side. So together it helps you say yes. And then one side at a time, it helps you say no with your head movements. It's actually not so much yes. It's more like sticking your chin forward and pulling your head back. Let's see if I can get my muscle guy to do it. Muscle man, where are you today? Let's see. So nope, he's not on that one. I'm gonna show him on this one. Here's sternocleidomastoid. Flexion of the head. Or flexion of the neck. And this is, oops, sternocleidomastoid. When we stretch our neck, lateral flexion. Levator scapula is D, well, levator scapula is in the posterior and this is in the anterior. So if I come back here, let's see if I can take this guy out. Let's fade. I don't think you're even going to see him on here. So levator scapula is going to elevate your scapula, but it comes up into your transverse processes. So it's more in line with the scalenes, not so much the, so splenius capitis is like the more superficial to both of those. So scalenes would be the anterior and the posterior would be levator scapula. Okay, let's see. Head rotation. There you go. Let's pull them out. So let's go back to this. Let me go in here. Okay, so when I was saying like pulling your head forward and back, I mean like this. It also does this. I know, strange. Strange, but I have a video. Okay, so let's put the awesome guy on. Sternocleidomastoid.
The sternocleidomastoid, or SCM, is located on the lateral and anterior aspects of the neck. It has a large belly with two heads, a flat clavicular head and a slender sternal head. Both heads merge to attach behind the ear at the mastoid process.
So since the sternocleidomastoid, or SCM, is so superficial and easily visible, let's begin by engaging it. I'm going to just rotate my partner's head a little bit to the opposite side and ask him to just raise his head off my hand, just a pinch. Fabulous. So he's flexing the neck, and there we can see a fabulous example of the sternocleidomastoid on the side and the anterior surface of the neck. Good. And go ahead and relax. Now there are three bony landmarks that are going to help us isolate where the SCM is. The first is going to be the mastoid process. It's located right here, right behind the back of the earlobe. I just set my fingers on that very large portion of bone right here at the base of the head. And so the sternocleidomastoid is going to attach there and come down to attach at that medial portion of the clavicle here, and then the very top of the manubrium right there. And if I ask him to go ahead and raise your head slightly, fabulous. There we can see that sternal head, this very skinny tendon attached right to the top of the manubrium. And here we can see that broader clavicular head attached to the clavicle. And then both heads ascend up the neck to attach to the mastoid. Good. Go ahead and relax. So to get my fingers on this muscle, I can really just grasp and use sort of a pincer palpation to just lift up the SCM here all the way up to the mastoid and all the way down to that clavicle there. Now, let's take a moment to notice something. Passing underneath the medial side of the sternocleidomastoid is the carotid artery. So let's figure out exactly where that is so that when we're grasping the SCM, we don't, well, pinch off the blood flow to our partner's head. So what I'm going to do is I'm going to just set my finger right along the medial portion of that SCM. And sure enough, there's the really strong pulse of the carotid artery. And it runs and passes right up along that medial edge. If I'm grasping the SCM and I feel that pulse underneath my finger, just release and readjust. Finally, to shorten the SCM, I can rotate the head to the opposite side, and you can see where the attachment sites get closer together. And to lengthen it, I can rotate the head to the same side, and there you can see where these attachment sites and the attachment site here at the base of the head get further apart. So we can shorten it by rotating to the opposite side and lengthen it by rotating to the same side.
Cool. All right, splenius capitis. Would it be contra to work on somebody with shunts in the neck? Oh, yeah. If somebody has stents in, well, so they probably have it right there in their carotid artery just because they need better flow. So I would say, our next page is 168. I would say yes, it would be contraindicated to work where the stents are directly. But if they've had this for a really, really long time, I would have them talk to their doctor and see, if you're not in the anterior neck, could you work in the posterior neck? Would that still be okay? Yeah, so like you said, they've had it a really long time. I would just have them ask the doctor, can I have any massage there? The doctors would be the best ones to tell them if that's okay or not. And then go from there. Okay, splenius capitis. What a splendid cap you have. Splenius capitis. Really cool muscle. So it's up on your occipital ridge and it comes down all the way to T3, holding your head on for you. So origin C7 to T3 spinous processes. So this is on the spinous processes. So this is a pretty superficial muscle, but it is deep to trapezius. And then it comes over and inserts onto the mastoid process of the temporal bone to the nuchal line. Under our occipital ridge kind of is the nuchal line. It's just like a ridge. Just another bony landmark. T slide deep to levator scapula. I'm reading in the little red box while you guys write this down. It gets its name from the term for bandage because of the appearance of the wrap around deep neck muscles. Splenius capitis lies deep to levator scapula. So I'm guessing that's showing you where levator scapula is in the red. It's a little weird. And its actions. So neck muscles. Sometimes it's hard to tell whether it's just moving the head or it's moving just the neck. Usually it's moving the head and the neck. So bilaterally, extension of the head and of the neck, head and neck. Unilaterally, flexion of the head, neck. Flexion of the head, neck, and rotation of the head, neck to same side. Oh, I see. The other one was the transverse processes of splenius cervus in the other picture. Okay. All right. We ready for my muscle man? So this is on the rotation. So much. All right, let's see. Nope, it's going to be up here. Sometimes my little program doesn't have what I want. Ah, that's a good picture. Splenius capitis. Head rotations. Go away. All right. I don't think they're going to have them in anybody else, so maybe this one. So here you can see trapezius, and then you can see splenius capitis. So let me get him out of here. So that's extension. So that's bringing the head back. I think that's the only two we're going to get. All right. Who am I looking for?
The long splenius capitis is located along the upper back and posterior neck. In contrast to the other back muscles that run parallel to the spine, the splenius fibers run obliquely. It is deep to the trapezius and rhomboids and attaches to the mastoid process between the trapezius and sternocleidomastoid.
So the splenius capitis, sort of like the Rodney Dangerfield of neck muscles. It just doesn't get any respect. But I really don't know why, because it's a great muscle, and let's give you an idea of how you can access it. So first of all, I'm going to just locate that superior nuchal line of the occiput right here. That's that bony ridge, which sort of serves as a shoreline between the bone of the head and the muscles of the neck. And right there is that mastoid process. And the splenius capitis is going to attach right there and then come down and attach at the spinous processes of C7 to T4. Now, most of the muscle is deep to the trapezius, but there's a portion right here that's totally superficial between the edge of the trapezius and the sternocleidomastoid here. There we can see the trapezius. If we take that away, there we can see the splenius capitis. So what I'm going to do is I'm just going to ask my partner to just raise your head straight up. Great. And I'm going to find that lateral edge of the trapezius right there. Great. Go ahead and relax. And then I'm going to leave my fingers there, and I'm just going to walk a little bit further lateral right here. And that tissue, real superficial, there's nothing on top of it, is going to be that portion of the splenius capitis that's completely accessible and available. And it disappears into that portion of the head right here at that superior nuchal line and a bit of that mastoid process right over here. And I can just set my fingers in, and I can follow them inferiorly as they disappear underneath that trapezius. And just to feel them engage, I can ask my partner, just this time, go ahead and try to rotate your head to the right. So he's rotating his head to the same side. And sure enough, wow, this muscle tissue really contracts. And I can be pretty sure that this isn't the trapezius, because here's the trapezius and it's nice and relaxed. But that tissue right there with those oblique fibers is going to be splenius capitis. Great. So with that in mind, now let's turn our partner supine and see what we can find in that position. Now, when we were prone, we were palpating his right splenius capitis. But now we're just going to palpate his left for viewing purposes. Okay, here we go. I'm going to first locate that mastoid process where the SCM attaches. And then I'm going to walk my fingers back as the mastoid process becomes that superior nuchal line right there. And here's that edge of the sternocleidomastoid. And I'm going to lift his head up a little bit. And here's the edge of that trapezius. So I know that in that space between right there is going to be the splenius capitis. So I'm going to just set my thumb right in that spot, right there. And if I ask my partner, just try to rotate your head to the left. So he's rotating his head to the same side. That tissue right there engages. And I can also feel as he does that action that those trapezius fibers are doing nothing. Good. And go ahead and relax. So now that I know that I'm on the path of the splenius capitis, I'm just going to work my thumb down inferiorly as it passes underneath the trapezius and goes to those spinous processes of C7 to T4. And notice that I'm kind of rotating the neck as I do so, which sort of softens up some of the tissue and allows my thumb to get in there. Good. And finally, to shorten the left splenius capitis, I can rotate the head to the same side. So I'll rotate the head to the left. And to lengthen that left splenius capitis, I'm going to rotate it to the opposite side. And that's that great place right there where we can locate it. Super. So tell me that muscle doesn't deserve some respect.
Gosh, I hope most of you guys know who Rodney Dangerfield is. But if you don't, he's a really old comedian. Comic. All right, so let's take a little break, like 15 minutes. So it's 7:11. So 25, right? Is that 25? My math is terrible today. So 10 to 15, 15 to 20, 25. Okay, 7:25, 15 minutes, because I went a little extra long. See ya. Okay, back from break. Recent drawings. Back and back. Just making sure nobody threw a question in there. Okay. All right, perfect. All right, let's see. Masseter. The mass eater. Masseter, page 144. Why do I have it on 144, but it's not on 144? It is on page 145 in my book. $145, masseter. Okay. All we have is one slide. Okay. So origin is a zygomatic arch. So your cheekbone and your insertion is the lateral surface of the mandible. And the action is elevation of the mandible. So it brings your jaw back up. So your masseter. So everybody can feel their masseter. You put your hand on that angle of your mandible under your lower teeth, you can feel your masseter right there. And if you clench your teeth together, it should come up real big. There you go. There's your masseter at work. Yeah, a lot of us clench our teeth, getting work here done. Really helpful for us. And this is showing you the masseter helping with the temporal muscle. Our zygomatic arch right here, that nice cheekbone. Some of us have very prominent cheekbones. Okay. And masseter.
The masseter is the strongest muscle in the body relative to its size. It is composed of two overlapping bellies. The superficial belly can be accessed from the face. The deeper belly is palpable from inside the mouth. The masseter is situated deep to the parotid gland, yet is easily palpable.
So the masseter, strong enough to bite off a human finger. But we're not going to do that today. Instead, we're just going to chew a little bit of gum. I gave my partner a big old piece of Hubba Bubba, and there you can really see the masseter on the side of the mandible really engaged. And go ahead and just clench for a moment. And there you can even see some of the muscle fibers running this way vertically up to the zygomatic arch. Great, go ahead and keep chewing. There, just behind the eyebrow, we can see some of the temporalis as it sort of dimples the side of the head there. And what's really interesting is that you've got two masseters and two temporalis muscles contracting constantly all day long and putting terrific strain right here on that small little temporomandibular joint right there, 4,000 to 6,000 times a day. Well, let's lay our partner supine and we'll palpate from there. So my partner supine, and I'm going to locate some of the landmarks that isolate where the masseter is located. First is going to be this edge of the mandible right there. There's the angle of the mandible, and it comes up this way. So right along there. And then we've got the zygomatic arch running right along here. And that portion of the cheekbone, I can even roll my fingers across right here. Well, in between this span of bone and that span of bone, as we can see right there, will be the masseter. And if I ask my partner to go ahead and just clench your jaw a little bit, wow, there's a very clear rectangle of muscle that spans from here on the mandible all the way up to that zygomatic arch. Good, go ahead and relax. And what I can do is I can just set my thumb right on that tissue and feel for the fibers of the masseter. Now, I'm going to be working through the parotid gland, so just something to be aware of. And then if I ask my partner to clench again, wow, that tissue really engages. Here I can even feel that anterior edge of the masseter as she engages, and as she relaxes, it seems to disappear. So all of that chunky mass of tissue right here on the side of the jaw is going to be the masseter right there. Finally, if I wanted my partner to lengthen her masseter, I could ask her to just open your mouth. And if I wanted to shorten it, I could ask her to close her mouth.
Okay. That's it. That's all that we have for our structure. That's the last one. So we're going to go to our review for digestion. We did indicus, pollicic, and minimi. So give one function of saliva. Good job. Oh, question. These are all really great answers, you guys. Good job. Functions of the saliva are to moisten the food, helps create a bolus so it can be easily swallowed, begins the chemical breakdown of amylase and lipase. So good job. What's the name of the food pipe? Good job. Sure, I'll go back in 1 second. Okay, are you good with this slide? Correct. The name of the food pipe, you guys are correct. It is the esophagus, also called the gullet. So I don't know, Denise mentioned that, they say this is also the gullet, but we use the term gullet usually for birds and any of you guys live by the coast, you see, what's that big bird with the big beak? Gosh, yeah, the pelicans. The pelicans sit all the fish in their gullet right before they swallow it down. Oh, you call it a gullet in Farsi. Interesting. Yeah. So usually we use the term here, gullet, for just for birds. Functions of the pancreas. Or what are some functions of the pancreas? Good. This is going to be weird. Hold on. I got to change this. Let's see. Okay. The pancreas secretes enzymes into your digestive tract for the endocrine, for the exocrine. For the endocrine, it secretes hormones like insulin and glucagon for your blood glucose. For your blood sugar levels. So yes, it makes pancreatic juices that flow into the small intestines. It also helps alkalize the chyme that comes out of the stomach, so it's not so acidy. Changes the acidic level. Nutrients are absorbed through which type of blood vessel? What blood vessels do nutrients get absorbed through? Capillaries, good job. Capillaries are always the ones gonna do the exchange. Capillaries always do the exchange. And this is a picture of our villi collecting and our capillary bed in between. Functions of the gallbladder. What's gallbladder do for us? Good. Good. It stores and concentrates bile, a digestive enzyme produced by the liver. So remember when we had the pluck and we showed you that little green sac on the pluck? That was the gallbladder. And that was going to be, that's where it was storing all that bile. So it's like a pouch to store the bile. What's a function of bile? Some of you guys already wrote it. Good. It breaks down the fat so it can be absorbed. It breaks down fat so it can be absorbed. So bile breaks down fat. Which organ is considered the great organizer and why? Or you can just tell me which one. Yeah. It's the liver. The liver is the great organizer. And it decides where all the nutrients goes. Plus it does like 200 different functions. The liver does a lot for us. And some of us are super mean to it. No, it's crazy how much the liver does for us. No. So remember, when those drinkable holidays come, remember your liver. Maybe you should be a little nicer to it. Name 3 parts of the large intestine. Good. Great job. We're talking about the large intestine. Some of you guys are putting stuff for the small intestine. Yeah, you're getting it, you're getting it. Good job, good job. Awesome, okay. So we have the ascending colon, the transverse colon, and the descending colon are the 3 parts that we wanted you guys to talk about. So yeah, some of you guys put rectum on there. Yeah, that is part of your large intestine. But specifically, we wanted to know about these 3 colons because they are the major action players here in your large intestine. Your rectum just has one end job, right? But the rest of your colons are finishing up, getting the rest of the water out and, you know, forming your feces as it moves through. Functions of the large intestine, which is what I just told you. Yep. Good job. To absorb water and electrolytes, to producing and absorbing vitamins, and forming and propelling feces towards the rectum for elimination. Yeah, compacting. So lots of absorbing and forming. The rhythmic contraction of smooth muscle in the intestines is called good job. Yep, great job. Peristalsis, that wave-like motion in the smooth muscle that's moving. Peristalsis, wave-like muscle contraction. Sure. This one or this one right here? All right, let me know when you're good. Okay. The rhythmic contraction, you're welcome. Smooth muscle is called peristalsis. And a function of the kidney. Honestly, I don't have the answer to that. If it's not a yellow note, should we not worry about it for the final? I haven't really looked through the final, but I have stuff for the final later. And we'll go over digestion. Good. Good job. And you guys got new videos to watch. I'm kind of jealous. I didn't get to see those. I'm gonna have to take some time to watch those little videos you got to see. The kidneys filter blood, filter H2O, water, create urine, and help synthesize vitamin D. Kidneys are a big old filter. And synthesize vitamin D. Through which digestive structure does 90% of your nutrients get absorbed? You're on it. your small intestines. Your small intestines absorb 90%. So some of you guys put specific names of parts of the small intestine. So I wanted to know like the whole structure, the whole small intestine, not just some parts. It's okay. Oh, so we're coming into polls. So before we start polls, let's take a, I don't think it's been long enough. Let's do the polls. There's not that many polls. Let's see, where are my polls? Polls. Largest organ, largest internal organ, answer in the poll. Getting ready to close the poll. Majority picked the liver. And you are correct, Mundo. The liver is the largest internal organ. Where does the most nutrients absorption occur? We just had this question asked in another way. Getting ready to close the poll. Majority said small intestines, and you were right. We just got asked, where does 90%, what structure has 90% absorption? Right, small intestines. What accommodations might be necessary for a client with cystitis? Cystitis. Yeah, I know you guys talked about this. Getting ready to close the poll. Majority picked frequent bathroom breaks, and you're correct. So cystitis isn't contraindicated, but they would need, because it's an inflammation, they would need frequent bathroom breaks. Cystitis. Inflammation of the bladder. Cystitis. Yeah. So I don't know if you heard me. Inflammation of the bladder. Cystitis. Usually called a UTI. What is a function of the liver? Okay, we're ready to close the poll. Majority picked removing the toxins. And you guys are correct. Removal of toxins is a function of the liver. Which of the following is the building up phase of metabolism? Okay, ready to close poll. Most of you picked anabolism, and that is correct. The bile that is produced in the liver breaks down what? Getting ready to close the poll. Majority picked fats. Fats is correct. The bile that the liver produces breaks down fats. What type of food is broken down by amylase in the saliva? Getting ready to close the poll. Majority of you guys picked carbohydrates. And you're correct. Saliva. Amylase in the saliva helps break down carbohydrates. That's why when you put bread in your mouth, it just starts to dissolve. It's 8:15. I think we should go on break. 10 minutes. 8:25. I'm so glad. All right, I'll see you in a few. All right, back from break. You guys are doing great. All right. Next poll. The rhythmic contractions of smooth muscle in the intestines are called. And getting ready, close to poll. Most of you picked peristalsis. Majority, look how many. You correct. Peristalsis is the rhythmic contraction of smooth muscle in the intestines. Which of the following is a function of the kidneys? I'm getting ready, close poll. And majority of you guys picked controls, the composition and volume of the blood, which is correct. Kidneys controls the composition and volume of the blood, and filters. Too little insulin is produced or the body is resistant to insulin. Increased urination and thirst may be a first sign of what? Sure, I'll go back in a minute when I finish this one. Great job. I'm closing the poll. %. Everybody chose diabetes. And you guys are so right. 100% diabetes. I know, 100%. Everybody pick the same one. It's amazing. I love it. It's a big one. So I'm gonna go back to this one real quick. Oh, before this one. This one? Perfect. Let me know when you're good. Okay, good now. All right. Everybody's good with this one. I go one yes, so that means everybody's good. Perfect. All right. Next. The pancreas secretes insulin in order to have what effect? I'm gonna get ready to close the poll. All right, majority picked lower the blood glucose level, and that is correct. The pancreas secretes insulin in order to have the effect of lowering the blood glucose level. Which structure acts as a storage pouch for bile? All right, closing the poll. Sharing. Majority of you guys picked the gallbladder, which is correct. All right. After this, Could you return one slide? Sure. Yep. Here you go. Let me know when you're good with this. Perfect. Okay. Did that one, and this one is the next one. Which structure connects the stomach to the large intestine? Looks like it tricked you guys a little bit. Are you ready to close the poll? The majority of you guys picked small intestine, and you're correct. Your small intestine connects the stomach to the large intestine. Which muscle would primarily be affected by TMJ dysfunction? Getting ready to close the poll. Okay, so yes, masseter would be the muscle that is primarily affected by TMJ. So that is the temporal mandibular joint right at your jaw. And so your masseter would be the muscle right there at your jaw that would get bothered by that. I don't have flashcards for these ones. So masseter is the answer. Yes, I can go back to the last slide. Let me know when you're good. Let me know when you're good with those. Oh, good, good, good. Okay. Well, somebody asked me to go back, so hold on. All right, let's launch this one. Scaphoid, lunate, triquetrum, I'm always bad with that name, are all in what group of bones? Oh, closing the poll. And carpals is correct. All of these bones are in your carpals. Hand bones. Them hand bones. They are hand bones. No, there's no other slides after the small intestine answer. That is it for those. Diarthrotic joints are also called joints. Allow for great range of motion. So these last couple of poll questions, I don't have slides for. Okay, I'm going to close the poll. Most of you guys picked synovial and you're correct. So diarthritic joints are synovial joints. You can't see my screen. It should just be a poll question. Can you see that? Yeah, that's all it is right now, is a poll question. Okay. So that's all the polls I have. And I have a crash course video I want to watch. So let's watch a crash course. Oh, let me put you back to there. Hi, hold on. Okay. Crash course, where are you? Let's see. Oh, and let's go number 1. Sure. That's always a good thought, number 1.
We all have our reasons for eating nachos at 3 in the afternoon. I happen to have my own. And don't ask, it's personal. But more generally, we all eat any kind of food to accomplish 2 simple things: to obtain the energy we need to stay alive, and to get the raw materials required for building all of our tissues and stuff. That's because when it comes down to it, both you and the food you eat contain those 2 same things. Both you and food are made of stuff, by which I mean matter, made of certain kinds of atoms, and both you and food have energy stored in the bonds between those atoms. So all living things need to take in stuff and energy and convert it into slightly different stuff and energy. And you can get some of the things you need pretty easily, like in order to get oxygen for respiration, to unleash the chemical energy in your food, you just have to inhale. But you can't just breathe in the stuff you need to build DNA or actin or a phospholipid bilayer. So, how does your body really acquire stuff? That's where the nachos come in. This cheesy, crunchy dish is made of all different kinds of biological matter, like carbohydrates and fat and protein, and it contains a certain, probably shocking amount of calories, which is how we measure energy stored in the chemical bonds in food. So if I take like a 100-calorie bite of nachos, which probably with this much cheese wouldn't even be a very big bite, I can convert the chemical energy stored in those carbohydrates and proteins and fats to feed my muscle and heart cells and maybe like walk a mile, an activity that happens to use about 100 calories. But I can't just swallow the nachos and watch the lump of them travel straight to my heart or leg muscles. In order to actually use this food, I have to convert the biological matter into something my body can work with on the cellular level, which, as you know, is pretty darn tiny. And the work of converting the stuff in food into the stuff that's in my body is done by my digestive system. Human digestion occurs in 6 main steps, some of which you are intimately familiar with, others less so. But every step of the way, your body is working to reduce all the different kinds of molecules in food into their tiniest and most basic forms. The first step is probably everybody's favorite. When it comes to what your digestive system ultimately does, just think of it as a sort of disassembly line. You could have an order of nachos with the works. I'm talking beef and onions and sour cream and slices of jalapeno, and your digestive system will deconstruct it, both mechanically and chemically, 1 step at a time. It's gotta do this because your cells work best with materials that are in their most basic form. Your digestive system reduces food to that level in 2 main ways: by physically smashing it to smithereens and by bathing them, as much as it can, in enzymes. Enzymes are proteins that living things use as catalysts to speed up chemical reactions. When used in digestion, enzymes break down the large molecules in your food into the building blocks that your cells can actually absorb. Those large molecules are called biological molecules, also known as macromolecules, and everything that you eat, I hope, is at least partially made of them. And there are 4 main kinds. You got the lipids, the carbohydrates, the proteins, and the nucleic acids. Each possesses its own density of chemical potential energy, or caloric value. Like, for example, 1 gram of carbohydrate contains about 4 calories, while a gram of fat contains about 9 calories. But many of these biological molecules are polymers, or sequences of smaller molecules, and your cells aren't really equipped to take them up whole. What your body traffics in are those polymers' individual components, called monomers, and there are 4 main kinds of those molecules too: fatty acids, sugars, amino acids, and nucleotides. The simple idea behind the whole digestive system is to break down the polymers of macromolecules in your food into the smaller monomers that your cells can use to build their own polymers, while also getting the energy they need. And what your body needs to build at any given moment is always changing. Maybe you need new fat stores so you can have energy to run a marathon, or new actin and myosin to build bigger muscles, or more DNA so you can replace the skin cells you scraped off your knee when you fell, or more enzymes so you can digest more food to get more building materials. To meet your body's constant and constantly shifting demands, your digestive system requires a lot of organs that perform a lot of specific tasks to break down and absorb the right nutrient at the right time. Now, I'm quite sure that you're familiar with the key players here. They're the hollow organs that form the continuous tube that is your alimentary canal, aka the gastrointestinal tract, which runs from your mouth to your anus. It's worth pointing out that these organs are hollow because you are basically hollow too. Your digestive tract is really just one unbroken, insulated tunnel of outside that just happens to run through your body, and it's open at both ends. You're a donut. So the layer of stratified squamous and columnar epithelial cells that line your tract is actually a barrier between the outside world and your inside world, but it's a barrier that allows for the selective movement of materials between them. It's these hollow organs that do the actual moving, digesting, and absorbing of food, and they include your mouth, pharynx, esophagus, stomach, and small and large intestines. In your mouth, in your esophagus, and at the other end of things at your anus, you have stratified squamous epithelial tissue, just like your epidermis, to help resist the abrasive action of chewing corn chips maybe. From your stomach on down though, the inner GI tract is lined with simple columnar epithelial cells which secrete all sorts of stuff and which absorb and process various nutrients. Most of these columnar cells secrete mucus, which lubricates everything and protects your cells from being digested by your own digestive enzymes. So the innermost epithelial layer of the tube is known as the mucosal layer, and it contains some connective tissue as well, which supplies it with blood. Surrounding the mucosal layer is the submucosal layer made of loose areolar connective tissue, which helps provide the elasticity that the tube needs when you eat a whole pizza in one sitting, and it contains more blood vessels. And outside that, you have the muscularis external layer, which, as you might guess, is where you find the muscles responsible for moving food through your tube. Beyond these layers, the GI tract gets tons of support from the accessory digestive organs like your teeth and your tongue, your gallbladder, salivary glands, liver, and pancreas. They're kind of like a pit crew, and they mostly help by secreting various enzymes that help take apart food as it comes down the tube. Together, these two groups on the digestive disassembly line work in 6 steps to destroy your food and release and recycle its nutrients. First, of course, you gotta introduce the food to your digestive system. What you know as eating or ingestion is basically just creating a bulk flow of nutrients from the outside world into your tissues. This is where the work of disassembly begins, in your face hole, which scientists call your mouth. Now, we're gonna get into the details of what happens here another time, but remember that food disassembly is both mechanical and chemical, so your teeth pulverize the bite of nacho or whatever, while your salivary glands begin that food's hours-long enzyme bath. But the food at this point is not nearly micro enough to be of any use to your cells, so you have to move that mush further down your tube. This stage is called propulsion, and its initial mechanism is swallowing, which, as you know, is a voluntary action, but then it's quickly turned over to the involuntary process of peristalsis. In peristalsis, the smooth muscles of the walls of your digestive organs take turns contracting and relaxing to squeeze food through the lumen, or cavity, of your alimentary tract. Waves of peristalsis continue through the esophagus, stomach, and intestines, and they're so strong that even if you were hanging upside down while eating your lunch and drinking your tea, the food would still soldier on, fighting gravity, and eventually make it to its final destination. Don't do that, though. There's other reasons why you shouldn't be upside down. Anyway, all of this shipping and handling mechanically breaks down the food even more, and even after it goes through the stomach and its gastric acid, the mechanical work still continues once it reaches your small intestine, as more smooth muscle segments push the food back and forth to keep it crumbling up. The goal of all this pulverization is to increase the surface area of that bite of food by breaking it down into increasingly tiny pieces to prepare it to encounter more enzymes in step 4, chemical digestion. Really, the actual process of digestion only occurs when the main action becomes more chemical than mechanical. And here, the accessory digestive organs, namely the liver, pancreas, and gallbladder, secrete enzymes into the alimentary canal where they ambush the mush and break it down into its most basic chemical building blocks. Like I said before, our cells prefer to do business in the basic currency of monomers like amino acids, fatty acids, and simple sugars, and digestion allows for the absorption of those nutrients as they pass from the small intestine into the blood by both active and passive transport. Once those nutrients are absorbed by your cells, you can finally use the energy inside of them or use them to build new tissues. The absorption of the nutrients is the goal of the entire process. But of course, it is not the end of it. Once your body has sucked out all the nutrients at once, indigestible substances like fiber are escorted out of your body. Yeah, I'm talking about pooping, or defecation. And that is the end of the digestive line, unless you are a capybara or one of the other animals who make sure that they get the most out of their lunch by giving the whole process another round and practicing coprophagia, aka eating their own poop. Now, you should notice here that some of the processes of digestion occur in just one place and are the job of a single organ. Like, hopefully you're only ingesting through your mouth and eliminating from the large intestine. But most of these 6 steps require cooperation among multiple organs. For example, both mechanical and chemical digestion start in the mouth and continue through the stomach and small intestines, and some chemical breakdown continues in the large intestine thanks to our little bacterial farm there. Over the next couple of weeks, we're going to take you and your nachos on a stroll through your digestive system and see who's doing what, where, how, and why. But for now, I got some nachos to finish, so I gotta go. And eating those nachos, as you learned today, will provide me with energy and raw materials by first ingesting something nutritious, propelling it through my alimentary canal where it will be mechanically broken down and chemically digested by enzymes until my cells can absorb their monomers and use them to make whatever they need, and eventually, there will be pooping. Thanks to all of our Patreon patrons who help make Crash Course possible through their monthly contributions. And if you like Crash Course and want to help us keep making videos like this one, you can go to patreon.com/crashcourse. Also, a big thank you to Peter Rapp, Sigmund Lervogue, Mikhail Moden, and Jeremy Brown.
Okay. So let me get out of this. How do I get out of this page? Ah, there we go. Ouch, 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 ouch. I know you want some nachos. You're so funny. Everybody else is probably like, no, I'm good. I don't know about eating. Right. All right. I do have one other crash course we can watch. This one.
Oh, hi. I hope you don't mind that I'm eating. This is actually just my first course. For my birthday, the writers wrote me a script where I just get to eat the whole time. And I can't think of a better way to demonstrate the workings of the digestive system, the series of hollow organs that we use to break down and process nutrients and energy we need to function. Though, wait a second. If I remember correctly, digestion is actually pretty freaking disgusting. So maybe I shouldn't be eating right now. But whatever. Waiter! The digestive system is so fundamental that it's basically step number 1 in the guide to how to make an animal. You probably remember that during the embryonic development of most animals, the digestive tract is the very first thing that forms. When the blastula, that little wad of cells that we all used to be, turns into a little wad of cells with a tube running through it, that tube is your digestive system. And pretty much every animal has a digestive system of some kind, but they're not all alike. Far from it. In fact, digestive tracts are specially adapted to animals' feeding behavior and diet. For instance, a housefly eats mostly liquid or very finely granulated food, but before it does that, it's gotta puke its digestive juices all over its lunch and then let them digest it for a while before it sucks it up into its mouth. If we did it like that, first dates would be less common. Most vertebrates put food in one end of the tube and our digestive system processes it, and then it gets rid of the waste out the other end of the tube. No muss, no fuss. Well, actually, there's a little bit of muss at the end, you may have noticed. But the beauty of it is that this whole process is run by our autonomic nervous system, so we don't have to think about it until maybe the very last step when we're in traffic and just had 2 cups of coffee and a bran muffin. Then we have to think about it a little bit. Among vertebrates, the digestive tract might be short or long or have organs that do different things depending on what its feeding habits are. For instance, dogs are mostly carnivores and also scavengers. They mostly eat meat, but sometimes that meat's been dead for a while. So the dog's digestive system has developed to take food in, absorb as many nutrients as possible, and then deposit it on somebody's lawn all in a period of about 6 hours. Dogs have an extremely short digestive tract because if you're in the habit of eating rotten meat, you'd better be able to digest it fast. If you don't, the bad bacteria that's probably living on that armadillo carcass is going to take up residence in your gut and put you in a world of hurt. Cows, on the other hand, take a very, very, very long time to digest their food, around 80 hours, because they have to process plants, mostly grass. Grass has a ton of cellulose in it, and evolution has yet to produce an animal that can manufacture a stomach acid or enzyme tough enough to break down cellulose. So cows have microorganisms in their guts that break down the cellulose for them. This process takes a 4-chambered stomach, each one with a slightly different microecology, and a lot of cud chewing, or regurgitating and rechewing of grass, before it passes all the way through. So nature is full of crazy digestion stories, and I honestly wish that I had time to tell them all. But let's focus on human digestion from now on, mostly because you're probably a human, we don't assume anything here, and you'll be wanting to know how your body does all this stuff. And 2, humans actually have a pretty good all-purpose digestive system. We're omnivores, after all. We eat plants and meat, so our systems are generalized to handle all kinds of stuff. Like most animals, humans have a bunch of different acids and enzymes in our digestive tract that break down food so that it can be absorbed and used by our bodies. But the secret to successful digestion is maximizing surface area, in more than one way, actually. The first way we maximize surface area is on the food itself. So say I take a bite out of this apple. Right now, it's like an apple boulder sitting there in my mouth. I got enzymes in my saliva that immediately start breaking it down, like the outsides of the boulder. As I swallow this chunk whole right now, not only would it hurt like heck, the rest of my digestive system would have a really hard time dealing with it because most of the enzymes and acids would have the same difficulty working all the way through this big solid hunk. But when I use my awesome teeth to chew up this hunk of apple, suddenly there's double, triple, quadruple the surface area on the food. I'm making up apple gravel from the apple boulder. Maybe even apple sand. For humans, chewing is key because breaking down our food into smaller and smaller bits allows enzymes and acids to get at them. And after our teeth have made the pieces small enough, the chemicals break them down further until they're fine enough for our bodies to absorb nutrients from them. But it's not just the surface area of the food that's important. The surface area of the digestive system is key to the whole process as well. Last time I talked about how we have a whole bunch of surface area in our lungs to absorb tons of oxygen all at once. Well, our digestive system works in much the same way. Most of the absorption of nutrients happens in our small intestines, and the length of the average human adult's small intestine is about 7 meters. Plus, inside our small intestines there are a bunch of little folds and little absorbing fibers with absorbing fibers on them, and no, I didn't misspeak, the fibers have fibers. That's how hard our intestines work to increase their surface area. Last episode I was all impressed that lungs have a total surface area of 75 square meters. Well, the small intestine has a surface area of 250 square meters. Ugh, it's kind of gross. I wouldn't want to see it spread out over a tennis court or anything. But I'm getting ahead of myself here. Digestion does not start at the small intestine, people. It starts at the mouth. Now, as you can see, this hot pocket is surrounded by some kind of bread, if you can call it that. Bread is a starch which breaks down into glucose. When I start gnawing on a piece of bread, look at the outside here, so it's mostly bread. The glands in my mouth start secreting saliva, which contains salivary amylase, an enzyme designed to break down starch into glucose. The more I chew, the more amylase will get to all the different sides of the bread, and that's why the more you chew bread, the sweeter it tastes. Amylase doesn't really do much to the meat of the cheese in this thing. I've got other enzymes and acids that are gonna work on them later on in the system, but I am gonna chew all that stuff up real good right now so that those other enzymes can do their jobs later. I'm gonna swallow all this. So now the masticated hot pocket has passed down my pharynx or throat and into my esophagus, which leads to my stomach. There's actually this little cool flap of tissue called the epiglottis that blocks the trachea when I swallow so that the food doesn't end up in my respiratory system. So this ball of food that I just swallowed actually has a scientific name. It's called a bolus, and it rides a kind of wave of muscle action down the esophagus into the stomach. This wave-like contraction of the smooth muscles around the tube of the esophagus is called peristalsis, and it's basically how most of the movement in your digestive system is accomplished. Now, my hot pocket bolus is in my stomach now, which is where the food really starts getting manhandled. The stomach basically takes a scorched earth approach to digestion. It's not messing around. It's like a churning cement mixture that can contract and expand with these big accordion-like folds of muscle called rugae. Your stomach's job is to turn everything over and over, smushing and mixing all the pieces up with its cocktail of acids and enzymes called gastric juice. Gastric juice is mainly made up of hydrochloric acid, an enzyme called pepsin, and some mucus and water. Hydrochloric acid has a pH of about 1, which is strong enough that if you got it on your hand, it would give you a chemical burn, so the acid breaks things down and hopefully kills most of the bacteria that you might find on your food. And the pepsin starts breaking down proteins into amino acids. Now that mucus is important. It's there to protect your stomach so that it doesn't, like, digest itself. When you don't have enough of that mucus, you get peptic ulcers, which happen when your stomach lining comes in direct contact with your stomach acid. And the water's just in there to make everything all soupy, because what you want by the time your food leaves your stomach is chyme, which is a kind of liquidy slop that you might be familiar with from the last time you had a stomach virus. You know, this conversation was gonna have to get a little bit gross, and I didn't want to bring diarrhea into it too much because, you know, I've been eating. But when something bad is going on in your digestive tract, your body doesn't worry too much about absorbing nutrients. It just wants to get the chyme out of there. So chyme is what you see when you get the picture. Anyway, there's a little valve or sphincter between the stomach and the small intestine that regulates how much chyme gets into the small intestine and when it gets in there. The very beginning of the small intestine is called the duodenum. This is where a lot of the small intestine action happens, by which I mean lots of things get absorbed and also secreted, like bicarbonate, which neutralizes the gastric acid before it goes any further. Now, the coolness of the small intestine can't be overstated. It's ground zero for cellular exchange of nutrients and the breakdown of fats. And again, the reason it's so good at absorbing is because all of the surface area it's got going on. A lot of that surface area comes from the fact that despite its name, your small intestine is frickin' long. In a human, it can range anywhere from 4.5 to 10.5 meters. But that's not all. The whole inside is lined with epithelial tissue that has tons of ridges and folds in it. Surface area to the max. And on those ridges and folds are these little hair-like fibers of flesh called villi. Each villus has capillaries on it so that it can absorb nutrients. And get this, each villus, which is only like half a millimeter long, is covered in teeny tiny little microvilli, providing even more surface area. In fact, apparently, the small intestine has a texture kind of like velvet, which is, oh, great, now I eat the milkshake? Fantastic. Okay. So another thing the small intestine does with the help of its friend the gallbladder is break down fatty stuff, like this milkshake. Near the top of your small intestine is a little pipe where bile salts manufactured by the liver and stored by the gallbladder are squirted out into the small intestine. Bile works like dish detergent on a pan you just fried something in. It's an emulsifier. It takes hydrophobic fat molecules and breaks them up into fatty acids and monoglycerides, which can be absorbed by all that epithelial tissue. I've never had Chunky Monkey before. Nuts. After your food passes through those yards and yards of small intestine, the chyme goes through another sphincter and enters the cecum, the beginning of the large intestine. The large intestine's job is to remove most of the water and bile salts from the chyme so you don't have constant diarrhea, so you can thank it for that. It's called large because it's wider than the small intestine, but it's not nearly as long. It's basically just a 1.5 meter victory lap around the outside of the small intestine, and then it calls it good. Also, should mention, at the end of the cecum there's a little tube where the appendix comes in. For a long time we thought that the appendix was a worthless vestigial structure that we used to need at some point in our evolution but didn't need anymore. However, recent studies are finding that the purpose of the appendix in modern humans is probably to act as a safe house for all the good bacteria you need to help you digest your food. If you get a virus or food poisoning or something and all your digestive systems say, "Get it all out of me!" the appendix has a little sample of your gut bacteria that it spits out to help you recolonize after your illness. So I think you're probably familiar with the final step in the digestive system. That's the pooping. Your food can spend as long as 3 days in your digestive tract, and a lot of that time is spent in the large intestine, mostly reabsorbing the excess water from the chyme and prepping your poo for its great entrance into the world. When it's done, it passes through everybody's favorite sphincters, the anal sphincters. There are 2 of them, and you know, out in the world to live its own life. And that's the end of our little tale here that begins with the Hot Pocket. I hope you join us next time for more disgustingness as we discuss the details of the excretory system. Until then, bon appetit. Thank you for watching this episode of Crash Course Biology.
Bon appetit. I mean, yeah, he got nachos and a hot pocket and a milkshake. I mean, man, that was a good day for him, right? So, anyways, I love the crash course videos. They're pretty fun. So, yeah. All right. So I have some review for the final for us to go through. Dan said you guys really liked how he did this, typed it out, and then this way. Perfect. So we're going to do this the same way. So we're going to start with the bones. Okay. Pauses. I don't type very fast, so for those of you who don't write very fast, that's pretty good. Osteoarthritis. So, of course. So what is a cause of osteoarthritis? And all of these are for the final. So these are all notes for the final. Good. So wear and whoops. And tear causing cumulative damage. Damage to articular cartilage. Cartilage is the answer. So your answer for causes of osteoarthritis is wear and tear causing cumulative damage to articular cartilage. Define I remember change these back. And then define resorption. Anybody define resorption? I got a great answer here. part of the process of bone remodeling refers to the breakdown bone tissue. Part of the process of bone remodeling that refers to the breakdown of tissue. Yes. Good job. And then our next one's going to be a function of spongy bone. What's a function of spongy bone? Yeah, it's a shock absorber. Okay. Define. It's like a little gnat in here and it's driving me nuts. Okay. Kyphosis. Yeah. Mm-hmm. Good job. And extreme or exaggerated curvature of the thoracic spine. Good. An extreme or exaggerated curvature of the thoracic spine. And then define lordosis. What's lordosis? Yeah. Good. Anterior. Curvature. In the lumbar. Spine. See. No, that's not what I want. This is sway. All right. All right, so you need to be familiar with bones that belong to the appendicular skeleton system. The appendicular skeletal system is, okay, so what's the appendicular system? So that is going to be the A, P, B, and I appendages, appendages. It's not gonna be right because I can't spell for my life. No. Nimbus. Appendages. Appendages. So the arms, legs, hips, shoulders, legs, clavicle. So everything that's not attached to the ribs. So like the ribs are attached to the sternum, and the sternum is, and they're attached to the spine. So the head and all that is the axial skeleton. So everything else, right? Does that help? So that's just some of them, but the appendages. For that, you don't need to know origin, insertion, and action because it's the appendicular skeleton. So if you have your coloring book, it's really helpful. Coloring book, page page 19. Okay. To help you with that one. All right. So if I was to ask you, in which skeletal system, the appendicular or the axial, where would the humerus be? Yeah, the appendicular, because it's part of the arm, right? You guys get it. You can look it up. It says, like, be familiar with rheumatoid arthritis. Arthritis. So it's a pathology, right? So it's a pathology. It's a condition. Stop. Condition is characterized as an autoimmune inflammation in the joints and can cause deformity. And what are osteoblasts? What are osteoblasts? Good job. They're a blast, right? Remember? They're a blast. They're bone forming cells. Bone makers. And what is osteoporosis? P-O-R. Osteoporosis. And yes, very good. Affects females. No. You can see I don't type very often. Okay, so osteoporosis is a condition that affects females in post-menopause and involves loss of bone density, which can result in spontaneous fracture. So next section. Do we need a 5-minute bathroom break? Yes, please. Yes, no, yes. Okay. There's a lot more questions. Okay, let's do a quick bathroom break. 5 minutes. 5 minutes. And I'll start typing out some of these questions while you guys take a 5-minute break. 5 minutes. Okay. 34, 35, 36, 37, 38. So 39. Be back at 39. All right, you guys got 1 minute to get back. Good. Good. All right. So circulatory. So can you scroll back up to rheumatoid arthritis? Okay, this break is over. So you're welcome. What chamber of the heart does the blood from the lungs return? Left ATR, left atrium. Good job. And then what vessels transport blood away from the heart? Arteries. Define erythrocytes. Erythrocytes are red blood cells. What is the only vessel that exchanges blood and tissue cells? The capillaries. Good job. Okay, scroll up a bit. Do you need more than that? Did you get what you needed? Yes, okay, perfect. All right. Know the chambers of the heart, right? We have 4 chambers. 4 chambers. The upper 2 are atrium. And the lower 2 are ventricle. Upper 2 are atrium, lower 2 are ventricle. Okay. And then define emphysema. Do you have my paper? You're quick with the answers. Destruction of the AL away in the lung. Fine. Necrosis. Cell death. Cell or tissue. Oh, no. Death. My goodness.
Hey, Mitty.
Hello.
Hi.
I thought I heard somebody on there.
It's me.
Hi, you.
Hi. Hi, everybody. It's Denise.
How are you? We're just doing some
I'm
review
okay.
here.
Yeah, it looks like you guys are reviewing for the final.
Yes.
Hi, guys. I came on because I said goodbye to the class on Sunday, thinking I wasn't going to teach anymore. And then you and I talked, and I found out I was going to teach, so I thought I'd came on and say hi. and say that I'd see them on the last one.
Yeah. They're all saying hi. Can you read your comments?
Yeah, I see that. Everybody's saying hi.
Yeah.
So yeah, I just thought I'd check in. I tried to sign in earlier, but I couldn't get in like an hour ago, so I restarted my computer like we're supposed to, and then it worked.
Huh. I wonder if I was playing a video and it was being weird for you.
Oh, maybe. What'd you play?
I played the crash courses.
Oh, nice. All right, well, I'll let you guys continue with your review of the final.
Yay. They say, yay, see you Wednesday.
Next Wednesday.
Yeah, next Wednesday. A week from today.
A week from today.
Yeah. Amazing.
Actually, you guys won't see me Sunday. You're gonna have
Just me.
Mindy on Sunday. I'll see you on Monday, Cynthia, for the last day of reflexology. And then I'll see you guys on the last day of class. Awesome. All right, well, I'm just gonna listen in for the last 10 minutes, okay?
Okay. Ooh, we need to like hurry. We need to hurry. Got 10 more minutes. Okay. So define necrosis is cell or tissue death. And what is the fluid portion of blood? It's plasma. Define pericarditis is inflammation of the sac around the heart. Right. Is that what we're putting? Yeah, it surrounds the heart. And then, good night. Are you gonna come say good night real quick?
Shut the door so Otis doesn't get in.
Okay, they can hear you. So good night. Okay. All right. All right. So I think I'm gonna keep going with maybe just the questions so that you guys can at least get those so you can have those to study by. What? Is Germany. vessels. What vessels have back low valves? Oops. And no that hard, lumpy, discolored, superficial veins. Nope. Are contraindicated for massage. Contraindicated for local and why doesn't it like this word? Too many S's. Where does homie Leases their place? Muscles that are most assisting respiratory function. I can't even type function. Good job. You are just on fire there, guy. You've done so good. What time is it? Oh, 4 minutes. Define the ischemia. Define hemoglobin. Let's see. Q, Wyatt, and muscles being contracted. Are the diaphragm, oops, and external intercostals. And okay. And define alveoli. And define MB and thrombosis. Process. Of massage on the cardiovascular SYS system who is to dilate the vessels. All right, it's 10 o'clock. So I'm going to leave this up for right here. And those of you guys who need to sign off, you sign off. Don't forget to study for your structure, and have a great night. Can I move it up? Move it up like that. Yes, lymphatic and digestion will be on the test. Are you saying we can stay for the rest? Yeah, your digestion notes will help on the test, and all the lymph notes that you took. Every time that we do a Wednesday night class and you guys take notes, those are all on the test. So, yes. Sam would zoom out to see if we, okay. I can see. It's 2 pages, so. I can't get the whole thing unless I make it really small. There's 100 questions on the test, just like, hold on, I'm gonna make this bigger. Okay. How many questions on the test? 100. Is this the last night of questions? Yes. I don't understand your question, Miriam. Okay, let me know Corey, when you need me to move it for the next section for you to take pictures. All right, tell me again. Hold on, Bob. I'm still online, dude. Okay. All right. No, we couldn't finish the whole thing tonight. All right, Corey, you good? You need one more section. You got it all? Perfect. All right, great. Yes, I can do that. I'll email them to you. I'll email you guys the questions. Somewhere I should have your emails. Yes, yes, yes. Okay. Yeah, I'm not going to finish the review. I'm going to log out. I'll just email them to everybody. I should have a list of everybody's email. Okay. Yes. Yes. I got you. I got you covered. Don't worry. Leave you hanging. All right. You guys have a great night. Log yourselves out. Okay. Go ahead and log yourself out for the night.